For the past several years, the artificial intelligence race has been measured by one question: who has the smartest model? Who has more parameters? Who has better benchmarks? Who can reason better? Who can build the next breakthrough? The assumption was simple: build a bigger model and you build a more capable AI. But something interesting is happening in 2026. The frontier of AI is beginning to shift because companies are discovering that intelligence alone doesn't create value, execution does. And execution requires something entirely different. It requires systems. Think about how work actually gets done. A financial analyst doesn't make a billion-dollar decision from a single piece of information. A surgeon doesn't perform an operation without continuously evaluating conditions. An engineer doesn't build a system in one attempt and walk away. Complex work happens through iteration. Observe, reason, act, evaluate, repeat. Human intelligence operates in loops. Increasingly, artificial intelligence is beginning to do the same. The first generation of generative AI was largely linear. You asked a question, the model generated an answer, the interaction ended. Today's most advanced AI systems are different. A modern coding agent can write software, execute tests, identify errors, and continue iterating until objectives are met. Research agents can retrieve information from multiple sources, evaluate conflicting evidence, and continue refining outputs. Operational agents can monitor systems and continuously reassess outcomes. The model isn't simply producing answers anymore. It's participating in a process. And that distinction may define the next chapter of AI, because intelligence is increasingly becoming a system property. It doesn't reside entirely inside the model. It emerges from the interaction between memory systems, tool access, and feedback mechanisms, and increasingly multiple cooperating agents. The result can appear dramatically more capable than the underlying model itself. Not necessarily because the model became exponentially smarter, but because the system around it became exponentially better at using intelligence. This shift is occurring for both technical and economic reasons. Training frontier models has become extraordinarily expensive. It requires enormous computing clusters, advanced semiconductors, massive amounts of electricity, and sophisticated infrastructure. So companies are asking, how do we extract more capability from the intelligence we already have? The answer is better systems and better feedback loops. Perhaps nobody captured this transition more clearly than NVIDIA CEO Jensen Huang. During CES 2025, he shared a powerful vision. He said, the IT department of every company is going to be the HR department of AI agents in the future. They will nurture and improve digital agents. He described AI agents as the new digital workforce. That statement may be one of the most important observations in AI today, because a workforce requires management. Employees require onboarding, access permissions, training, and continuous improvement. They require supervision and performance evaluation. Digital workers increasingly require the same things. An AI agent that cannot access information, use tools, or evaluate its outputs is ultimately just an advanced chatbot. But an agent operating inside well-designed systems starts to resemble something entirely different. It becomes capable of performing work. Once AI begins performing work, entirely new engineering challenges emerge: security, context retention, and multi-agent coordination. How do humans supervise decisions? How do organizations manage thousands or eventually millions of digital workers operating simultaneously? These are not model questions. They are systems questions. The next competitive advantage may not come from building bigger models. It may come from building better infrastructure around intelligence itself, the memory systems, orchestration layers, and governance systems. The next chapter is about teaching machines to operate continuously inside complex environments, to reason, to act, to evaluate, and to improve. The future of AI may belong not only to those building bigger brains, but to those building the systems that allow those brains to work. And that may be the real story of artificial intelligence in 2026. This is the shift we've been waiting for. As a reminder, this content is for informational purposes only and is not financial advice.